Now let's look at the second problem. It says the car is traveling at 88 feet per second. That's a velocity. This starts to decelerate. Hey, acceleration at a constant rate. Ooh, they didn't tell us. If the car travels 500 feet before coming to a stop, what was the rate of deceleration? Now this is not part of the problem, but 88 feet per second is exactly 60 miles per hour. So you see that number show up quite a bit. So what I want to do is do this problem in 2 bits too. Let's find the equations, and then in the second part we'll try to use them. So let's go find the equations first. All right, what we're told is that the car starts to decelerate at a constant rate, but we're not told the constant rate. So if I'm going to write down something, I'm going to write down A equals, and then oh phooey. Now I am going to call this minus k. We don't have to do this where k is bigger than 0. That way we know we're actually going to get a deceleration when we're all done. Now just a reminder that this is actually equal to dv dt. I'll just write equals minus k like this. And then from here, I'll take the antiderivative of both sides. Antiderivative of dv dt is just v of t. Antiderivative of minus k is going to be minus k t plus c. Now in order to find k, well, we can't find k. K is a deceleration. We might be able to figure out something about c. So I'm going to go back over to the problem and see what it says. It says it was traveling at 88 feet per second and started to brake. Aha. So what they're telling us there is that the velocity at the very beginning was 88 feet per second. That's 60 miles per hour forward. But we know how the velocity equation works. We're supposed to just put a 0 in for both t's. So we get that. And so we get a complete velocity equation, well, sort of. Complete as we're going to get, equals minus kt plus 88. That part's good. The next part is going to be awkward. What do? We usually write down that this is equal to ds dt. That's equal to minus kt plus 88. And we take the antiderivative of both sides. So over here, I'm going to get s of t equals minus 1/2 kt squared plus 88t plus d. Now d should have something to do with the starting position, but they don't actually give us a starting position either. So all we have from the equation so far is that the acceleration is minus k, the velocity is minus kt plus 88, and s of t has 2 constants in it, so it ends up being minus 1/2 kt squared plus 88t plus d. In the next part, we'll try to wrangle through what to do with all those constants.